In this lab exercise, we'll play a Windows Media video file which is stored on our local file system, which, in this case, is the Journaling Flash File System version 2, or JFFS2 for short. This file system is on partition 2 of the multimedia card that we're booting from. We'll also demonstrate the take-home lab exercises, where we'll first capture video from a USB webcam and display it on our exported desktop, and then play audio from the movie clip of Part A, but this time with the audio routed through a pair of external USB speakers. For Lab 3, we're going to use Linux's InPlayer application to view a Windows Media video file. This is a standard Windows Media video file that was downloaded off of the internet, and even though we're using an exported GNOME desktop and viewing this video file on our x86 host computer, keep in mind that the entire GNOME desktop, as well as the decoded video, is being generated exclusively on the AM3517 board. We'll assume that you've already completed either Lab 2C or Lab 2D, and as a result have your exported GNOME desktop set up. If you have the AutoFit Guest option checked in your VMware, then you can simply resize this window to whatever size is most convenient for you, which can certainly make it more helpful to navigate. It's going to start off probably in the native size of the LCD as it appears on the AM3517 board, which is how the desktop begins set up. Now, because we've booted off of a multimedia card, that multimedia card's partitions show up on our desktop. So if you're curious about how this MMC card was set up, you can double click on partition 1. You see we have the MLO, which is the name that you have to use for Xloader so that the ROMmed bootloader will recognize it and boot it off of the MMC card. Xloader is the secondary bootloader, which sets up the DDR2 RAM, and then boots U-boot, which is the tertiary bootloader, which is used to boot the Linux kernel. You also see Uimage, which is a Linux kernel that has the appropriate wrapper to be recognized by U-boot. Our file system is here on the second partition. If I double click there, it'll bring it up. And you see here exactly the same as if we were to open up a local file system window. As a matter of fact, I can do that. We'll start off in root home. And here in root home, if we go up a level, then you'll notice that this is exactly the same bin, etc., lost and found. You see it's exactly the same file system as we're viewing directly off of the partition of the multimedia card. Now on partition 3, we have all the files that are needed to install the rotating cube demo onto the AM3517 board, which we're going to explore in a later lab exercise. Once you've taken a look at that, you can go to Applications, Accessories, and Terminal and open up a new terminal. We're going to use this terminal to launch the InPlayer application. You do that just by typing the name of the application, which is InPlayer. It's already, the application is in the Linux path, so it'll find it. And if you do not have speakers attached, which say if you don't have USB speakers attached to the AM3517 board, you're going to need to use the -no sound option. InPlayer, unfortunately, if it thinks it should play sound but can't locate a suitable sound device, will lock up and not play the video. So if you have USB speakers attached, then you don't need to do this and you'll hear the sound. But if you don't have them attached, go ahead and use the -no sound option. Now you can either type -FS for full screen, or if you leave that off, then it'll play the file in the native resolution. Either way, and then you can simply type in the name of the file you want to decode, which in this case is the crowtrailer.wmv. As soon as we launch it, you see it displayed here in its native resolution. When you're done viewing the clip, you can simply press this X and it'll quit out of the InPlayer. Now the reason that we're seeing this video on our host computer instead of the LCD if it's attached to the AM3517 board is because of the display environment variable of Linux. If you want to see how it's set, we echo display. Now I'm using the secure shell, so it's going to be localhost 10.0. If you've done the direct export of the X Windows, then what you'll see instead is the IP address of your host computer and then :0.0. If we want to display the video on the LCD, then what we can do is temporarily override the display environment variable by putting display equals in front of the mplayer command. And if you say localhost, that is it's just another name for the IP address of the AM3517 board, which is the local board that all of this is being generated from. And then 0.0, which is the default screen, which will be the LCD. Then we can do mplayer, dash no sound again. Let's try dash FS option this time and do the crow. And this time it's going to display this video on the LCD board. So we can go ahead and launch that, and then if we take a look now at our LCD board, we see the video being displayed. So now when we start the mplayer, we see this trailer for Chronicles of Narnia. In Lab 3B, we'll attach a USB webcam to the AM3517 board via USB hub. We found greater reliability with this lab when the AM3517 board is rebooted after attaching the USB hub, so that the USB devices which are attached to the system can be recognized at boot time. Before we launch mplayer to display our webcam input, let's go through just some verification to make sure that the webcam has been recognized by Linux. So the first step is we can use the lsusb command, list USB, to see all of the USB devices that are currently recognized on the system. You'll notice here that bus 1 device 3, Logitech Incorporated, is in fact the Logitech camera that we are using. So once we see that the hub and camera have been recognized, so this is my external hub, this is my Logitech camera, and then I'm not exactly sure why there's two entries for the internal hub. But this is a hub that's part of the AM3517 board. So if your external hub and camera haven't been recognized, you should always see these two entries. But if the external hub and camera have been recognized, you should see 4 entries. Next, we can verify that a driver has been associated to the camera. And so there's an interface that's the proc interface, which is a file system of a whole lot of files that are maintained by Linux, containing various information. So if we go to the bus USB devices file, and cat is a command that will print this out to the terminal, then there'll be, for every one of those devices we saw in LSUSB, there'll be an entry. So you see some of those here. The one we want is this last one, which is bus 1 and device number 3. And you can see here that there's audio and video recognized. Now the way this USB driver works, there's kind of, for every mode that's supported, there's an entry listed here, but what you should see is multiple UVC video entries and multiple sound USB audio entries. If your USB camera doesn't have a microphone, then you'll see just the UVC video. Now the final check we can do is say list video, dev video asterisk. Now, video 1 and video 2 correspond to the video ports of the OMAP, the video ports that are actually on the device. Dev video 0 only shows up if you have a USB video device attached. So if you don't see Dev video 0, then you may want to reboot the system and try again, or go through some type of diagnostics. But if everything has gone through correctly, then you should see this device node, which indicates that the USB camera has been recognized, a driver, in this case the UVC video driver, has been associated to it, and that's been mapped into the V4L2 interface as Dev Video 0. At this point, we can use mPlayer to display the video from the camera. Now, this sequence of commands from mPlayer you can find by going through the mPlayer documentation, but for now you can treat it just as a cut and paste for how to use mPlayer to view the USB camera. Once you have that command typed in, you can press enter. We see mPlayer launch, and hello. This is me viewed through the mPlayer webcam. Before starting mPlayer to output our audio through the USB speakers, let's just run through some quick diagnostics to verify that the USB speakers have in fact been recognized by the system, and to determine the device and card that have been associated to them. So we can start with LS USB. You see again the two hub entries, bus 1 and bus 2. That's the onboard hub. And then you can see the external USB 4-port hub, which we have attached. And now you see these are the audio speakers, which are connected over USB. You'll notice they're listed as Texas Instruments. We'll see why in a moment. But they are speakers that use a Burr-Brown digital to analog converter, Burr-Brown now being a division of Texas Instruments. In order to see how they've been mapped, we can first use the cat command to display proc a sound for also sound, and then cards. And you'll see here the USB speakers have been attached via card 1. Card 0 is the ALSA driver associated with the AIC23 codec. That's an onboard codec that's part of the AM3517 evaluation board. Now, if we want to verify which device has been associated, we can cat the proc a sound devices. And now you see here for the two cards that are listed, there's a capture and playback device for the AIC23. That's because it's a codec. It has capture and playback. The USB speakers don't have any type of capture, so you see a control interface, a timer, and then just the audio playback channel. And you can see this is card 1, and the playback channel has been mapped to device 0. This gives us all the information we need now to invoke mPlayer, to do the crow trailer.wmv. We're going to use -AO to specify the audio output as ALSA, which is the driver, and then device equals hardware equals, and then card, which is 1, period, device, which is 0, as we've just seen. And now you can hear.
Experience the phenomenon, the motion picture event of the year.
And there you could hear that was coming from external speakers, the sound to that file, and one of my favorite Stone Temple Pilots songs.